Welcome back, everybody. In this video, we're going to go over section 8.2, which is about multiplying and dividing rational expressions. So for multiplication and division, basically the short directions are if you're multiplying a fraction that looks like P over Q times a fraction that looks like R over S. You multiply the numerators, you multiply the denominators, getting P times R over Q times S. Here's a quick just numerical example. If we had 3/4 times 5/8, we multiply across, getting 15 30-seconds. 3 times 5 is 15, 4 times 8 is 32. So that's basically how it goes. That's the heart of the whole section right there, or at least the multiplication half. Of course, it can be made simpler in a lot of cases by applying the fundamental property of fractions to simplify partway through. So here, for this example, 6/10 times 15/12, we could just multiply across. 6 times 15 is 90, and then 10 times 12 is 120. This one's not too bad, but as we'll see when it start incorporating variables and things, doing it that way is going to be harder, and we'll see that here in a minute. This one is not too bad. This simplifies to 9/12, which is 3/4, as we'll see. So rather than doing that, we want to see how it looks kind of more that we'll do the algebra problems. For this, we're going to use the fundamental property of fractions and divide the numerator and denominator by common factors to remove those common factors. So here, 6/10, 15/12. The 6 and 10 have a common factor of 2 that can be removed. So let me divide that out. So if we do that, we'll end up with 3/5 for that one. 15 and 12 also have a common factor of 3 that can be removed. So we'll divide the top and bottom by 3 at that point. And so from here, you can keep canceling if you like. I kind of like to rewrite the problem periodically just because it ends up with a lot of crossouts in it otherwise. This is 3/5 times 5/4. And now here you can see there's a common factor of 5 that you could divide out, and that's what leaves us with 3/4. Of course, this is the same as that you'd get if you multiplied across, getting 90 over 120, and then simplify that to 9/12. That simplifies to 3/4 as well. So that's great, but we'll see, as we'll see with a lot of algebraic problems, it's simplifying along the way is going to save you work in the long run. Before we proceed, I did want to remind you that when you have, say, 6/10 times 15/12, I chose to simplify the 6/10 first and the 15/12 first, but there's nothing mathematically stopping us from dividing through by 6 at the first step. And then 15 and 10 have a common factor of 5, which we could have divided out. And then multiply across, getting 3/4. The point is there's a lot of ways of doing this simplification. And sometimes there's an obviously better way, other times there's not. It doesn't really matter which steps you take. All right, so let's try one that's got some variables in it. Here we've got 6x cubed y over 7x squared times 2x y cubed over x squared y. So what we'll do on this one, I'm going to simplify the kind of each fraction separately, and then we'll deal with the multiplication. So x cubed and x squared have a common factor of x squared, which we'll divide out. That will leave just a single x in the numerator and a 1 in the denominator. And that's it for the first fraction. For the second fraction, we have an x in the numerator and an x squared in the denominator. If we divide the numerator and denominator by x, that will leave us with a single x in the denominator and a 1 in the numerator. Now, on this one, we'll be able to simplify y's as well. We have y cubed over y. When we divide out a y, that will leave us with y squared and then a 1. Okay, so let's see what's left after the dust settles. We'll have 6xy over 7 times 2y squared over x. All right, so I simplified each of the fractions kind of separately as much as possible. And now I can see that we can divide out that common factor of x, finally. And that will leave us with 12y cubed multiplying across the numerator. 6 times 2 is 12, y times y squared is y cubed, and down below just is 7. All right, and so that's how it goes. Again, there's different paths you can take that lead to the same place. If you felt like multiplying it all out first and then simplifying, you could have. Usually, though, it's better to simplify along the way. All right, so here's one for us to try. Another one. This one illustrates how it is easier to simplify kind of along the way. If I just multiplied across, I'd have 5x cubed minus 20x, down below something like 10x cubed, and then some other stuff. So we'd have some division of polynomials to do, and we want to avoid that here just because it's easier not to and less error prone. So instead, let's see about simplifying first. So what I'm going to do is begin by factoring everything. So we'll have 5x divided by x plus 2, x plus 3. That's our first fraction. And then x squared minus 4 is a difference of squares. So that's x plus 2x minus 2. Still have the 10x down below. If you're not liking factoring, you probably won't like too much of this section either, because we're going to end up doing some factoring, as you can see, throughout this section. So hopefully you are okay with factoring. All right, here we can see there's a common factor of x plus 2 that can be divided out. So let me do that. And then additionally, I can see a 5 that can be divided out. 5 divided by 5 is 1, 10 divided by 5 is 2. And then finally, we can divide out this x, which will leave us just with a 1. Okay, multiplying across what's left, that's 1 times x minus 2. And then down below, it looks like 2 x plus 3's. And then there's no reason not to just go ahead and multiply that out, getting 2x plus 6 in the denominator. All right, that's how that looks. Step up in difficulty here. This one you could try first. Take a minute, pause the video, try this one yourself, then restart the video and see how you did. All right, so for this one, it should be pretty clear that we're going to want to factor everything first as much as we can, remove any common factors, and not just multiply across, right? Because that's going to be more difficult. So let's try factoring. 12x minus 6x squared has a common factor of 6x. So if we factor out the 6x, that will leave us with 2x minus 6. Sorry, minus 1. No, I'm sorry, I'm off today. Hold on. All right, slow down. So 2x, it's factored out. That leaves us with 6. Okay, no. 6x factors out, leaving us with 2 minus an x. Okay, let me double check by multiplying that because I was distracted. So 6x times 2 is 12x. 6x times x is 6x squared. Okay, that's fine. Down below, I have an x that comes out. That leaves x plus 8. And then up top, we need two numbers that multiply to 24 and add to 11. That will be 8 and 3. So x plus 3 times x plus 8. Down below, difference of squares. X squared minus 4 is x plus 2. X minus 2. And then let's see what we can remove. I can see common factors of x plus 8. So let's go ahead and divide those out. And then I can see also a factor of x that can be removed from both the numerator and denominator of the first fraction. And then also I'm seeing a 2 minus x and x minus 2. And those guys are opposites of each other. So we can divide the top and bottom by x minus 2. It probably will be easier on you if instead I go ahead and factor a negative out of that first numerator. So let me do that. That's all gone. Sometimes it's a good idea just to insert multiple steps, especially if you're going through and crossing out a bunch of stuff. it's hard to tell sometimes what's left and what's been crossed out. All right, so -6 still here, or 6 is still here. I factored a negative out, which is how the 2 minus x turned into x minus 2. The yellow stuff and blue stuff is divided out. On the right fraction, we have x plus 3, and then the x plus 2, x minus 2. So now at this point, we have another common factor of x minus 2 that can be divided out. And that's all there is. So I'm going to go ahead and multiply at this point. We have -6x minus 18. And then down below, we'll have just x plus 2. By the way, once you get this far, you don't have to sit and kind of separately think about, okay, well, this fraction simplify. If it didn't simplify in the previous step, it's not going to simplify at this point either, so you don't have to try. Okay, so let's see what else we have. There's a couple more multiplying to do. So once again, take a minute, pause the video, try this one yourself, restart it, and see how you did. All right, while you were working, I went ahead and factored this. The numerator of the left fraction, there was a common factor of 3 that we were able to factor out. That left 3 times a minus 7. Down below, we were looking for two numbers that multiplied to be 14 and added up to be 9. And so that's 2 and 7. A squared minus 4, that's a minus 2a plus 2. And then down below, 3a plus 6, common factor of 3 came out. So once we've gotten everything factored, we can start looking for things that will divide out. I can see an a minus 7 in the numerator and denominator of the first fraction. So we'll go ahead and divide those out. And in the second fraction, I can see an a plus 2 in the numerator and denominator here. And then it looks like we get one more thing we can divide out. It looks like the a minus 2's also will divide out. It looks like everything divides out. That's really neat when that happens. We're going to get just a 1 actually out of this one. I wasn't expecting that to happen. Fun. So everything divided out, and we're just left with 1 this time. I like that. That's pretty fun. All right, so that's our last multiplication example. We want to go on to division next. All right, so dividing rational expressions. To do division, we need to know about the idea of a reciprocal. A reciprocal of a fraction, if you have a fraction a over b, its reciprocal is b over a. Some examples, 5 over 2x, its reciprocal is 2x over 5. We've just swapped the numerator and denominator. 4x minus 1 and 1 over 4x minus 1 are reciprocals of each other. Another way of thinking about two numbers being reciprocals is if their product is equal to 1. If you multiply together two numbers and get 1, those two numbers are reciprocals. Okay? So directions for doing division. If you've got 4 polynomials, p, q, r, and s, q, r, and s are non-zero, and you want to take p over q and divide it by r over s, you keep the first fraction the same, it's still p over q, but you turn the division to multiplication and then form the reciprocal of the second fraction. If you learned about division of fractions involving inverting and multiplying, that's this. So let me do a numerical example first, and then we'll do some algebra ones. If you wanted 3/4 divided by 5/8, you would turn that into 3/4 times 8/5. I turn the division to multiplication and the 5/8 into 8/5. And then we saw there's a common factor to divide out, and then this will leave us with 6/5 at the very end. Okay. You'll note also that you can't cancel across division. You can cancel across multiplication, though. So there is that. So division turns into multiplication, and then replace the divisor fraction, that is the second one, with its reciprocal, and then multiply, as we were doing a few minutes ago. Okay. So here I want c plus 3 divided by 5 minus c. We're going to divide that by c squared minus 9 divided by c minus 5. So what I'll do first is basically just keep the first fraction the same, change the division to multiplication, and then change the second fraction into its reciprocal. Okay, that's it for division. You just turn it into a multiplication problem, and we practiced that a bit, so Here, c minus 5 and 5 minus c are opposites. I'm going to factor in -1 out of that c minus 5. We'll see that happen. And also the c squared minus 9 is going to get factored as a difference of squares. Okay, so there's that. So now we can see that that 5 minus c divides out. And also the c plus 3 divides out. Okay, up top we'll have -1. Down below, c minus 3. Okay, so you can write it like that, or you can have the negative in front of the entire fraction if you so choose. Either of those is okay. So the whole point with division is you turn a division into a multiplication. Okay, and that's it for that page. All right, so we've got a couple of more division examples to do. Let's hide the big one for a minute. All right, so we've got 2m squared over m squared minus 8m. If you want to factor now, you can. I'm kind of holding off on that because I don't want to do too much in each step because you're just learning this stuff. But if you want to factor now, you can. I'm kind of trying to do one thing at a time. All right, so I replace the division by a multiplication and then the second fraction by its reciprocal. Now I'll go through and factor 2m squared in the top. Down below, we have a common factor of m. That leaves behind m minus 8. Up top, we have m squared plus m minus 6. That'll be m plus m minus 2. If you're slow at factoring, this is going to take you a long time. So make sure to practice your factoring. So then we're good there. Down below, we have a factor of 8m that can be removed. And that will leave us with m plus 3. All right. So make sure to double check your factoring. You're not guaranteed that stuff cancels, but math classes being the way that they are, you often get at least some canceling. So m plus 3's divide out here, and then what else? It looks like an m. Write it this way. M squared divided by m will be a single m. That'll turn into a 1. And then actually I get another m. I just saw that. So change colors. So there's one more m here, it looks like. Okay, now this is starting to get a little messy for me, so I'm going to rewrite it at this point. I think there's one more thing that can be divided out, but I'm going to wait on that till I make it neater because I don't want to make a mistake. And it looks like there's an 8 here that has a common factor of 2 without 2. So let's go ahead and divide that 2 out. Okay, so now we should be all right. So up top we'll have m minus 2, and down below we'll have m minus 8 and m plus 3, and then there was still that factor of 4. So here I've left this factored. You should always pay attention to the directions if you're taking a test or doing some homework or something. You'll need to know if you need to multiply this out or if you need to leave it factored just like that. For some purposes in math, it's easier if it's left factored. Some people feel like it's neater if you go ahead and multiply it out. So I'm going to go ahead and multiply it out. So we'll have 4m squared and then negative 20m and then negative 96. All right, so I kind of did two things right there. I multiplied out the binomial and also distributed the 4 at the same time. So let's make sure that's okay. M times m is m squared times the 4 gave 4m squared. FOIL for this, 3m minus 8m is negative 5m times 4 is negative 20m. 3 times 8 is 24, negative. 24 times 4, that's 48 times 2 or 96. Okay, so that will do it. All right, so this is kind of bigger and longer. Take a minute, pause the video, try this one yourself, and then restart it and see how you did. The factoring is going to take you a little time. All right, so I'm going to go through and factor all of this stuff. I'm going to work across then down. So the first one, 3a squared minus 8a minus 3. we're looking for two numbers that multiply to -9 and add up to -8. That sounds like -9 plus 1. So we'll have 3 squared minus 9a plus an a minus 3. So that will have a common factor of 3a in the front, leaving behind a minus 3. All right, sorry about that. Zoom crashed again. All right, so we have a minus 3 as a common factor. I factored that out, which left behind 3a plus 1. All right, so that's the upper left. And then down below that, I have a squared minus 25. A squared minus 25 will be a plus 5, a minus 5. Okay, and then on the upper left, or upper right rather, we need two numbers to multiply to -15 and add to -14. That sounds like -15 plus 1. Okay, and then we're going to factor that by grouping. In the first two terms, there's a common factor of 3a. Bringing that out, we'll leave a minus 5. And then we'll also have an a minus 5 sitting in the back. The a minus 5 factors out, leaving us with 3a plus 1. For the last one, we have a perfect square, right? Our a squared plus 10, a plus 25. That factors as a plus 5, a plus 5. All right, so we've gotten all of those pieces. So let me go ahead and rewrite our original problem, but factored. So the upper left factored as a minus 3, 3a plus 1. The lower left was a plus 5, a minus 5. And then here, because you've got a little more experience, I'm going to go ahead and turn this into a multiplication right now. So since I've done that, the a plus 5 is going to end up on the top, right? Because we're making a reciprocal at this point. And then the a plus or a minus 5, 3a plus 1 will end up on the bottom. So is in the process of recopying it with the reciprocal. I formed the reciprocal at the same time as the factoring. So that saves us just a little bit of time. So now we can see what we'll be able to divide out. So looks like an a plus 5 can be removed. So let's try that. And then we should be able to get a 3a plus 1 out. And then that's it, right? Can I cancel out those two a minus 5s? No, they're both on the bottom, so we can't divide out those. So what's left? We'll have a minus 3 and then a plus 5. And then down below, a couple of a minus 5s. And then it's probably a nice idea to go ahead and multiply all that out. So we'll have a squared plus 2a minus 15, and then a squared minus 10a plus 25. Okay. All right, that will do it. We have just about 3 more, and then we'll be all finished. So let's try this one. So here we have a squared minus b squared over 3ab, and then it's divided by a single polynomial. So for this, we're just going to replace the second fraction by its reciprocal, right? The first fraction will stay the same. We'll turn the division to multiplication. Remember that our original polynomial, we could always look at it as that polynomial over 1. So now we'll have 1 over that a squared plus 2ab plus b squared. All right, and so now we're going to factor again, right? So let's do that. So we'll have a plus ba minus b. And then down below 3ab. And then 1 over. And then that was a plus b times a plus b. All right, those a plus b's will divide out. One from the numerator, one from the denominator. And then multiplying across what's left, we'll have a minus b in the top. And then 3ab, a plus b, bottom. And We'll go ahead and multiply out that denominator, 3a squared b plus 3ab squared. Okay, and that's it. Last example, this one involves complex fractions. What a complex fraction is just a fraction that has got a fraction in its numerator, denominator, or both. So here we have 6x squared minus 7x plus 2 divided by 4x minus 8. And we're going to divide that by the other one, 2x squared minus 7x plus 3 divided by x squared minus 5x plus 6. So our approach to dealing with a complex fraction is to just rewrite it as a division and proceed from there. Before we go further, I did want to mention something that you need to be careful, yet another thing. Here are the division bars. It's a good idea to make sure that they're long enough that you don't misinterpret them. Just with numbers, let's say you had 3/4 divided by 5. Okay, you want to be able to know for sure, is this 3/4 divided by 5, or is it 3 divided by 4/5, right? If the fraction bars are not really different in length, then it can be hard to tell which one it is. And they're not equal to each other. Okay, I'll leave it to you to check that. But kind of make it really obvious who the main division line is. Okay, all right, so let's try this one. So once again, we're going to need to do some factoring. So let's do that. For the first one, we need two numbers that multiply to 12 and add to 7. That sounds like 4 and 3. So we'll have 6x squared minus 4x minus 3x plus 2. Common factor of 2x comes out, leaving 3x minus 2. Then we'll have to factor a negative out so that we end up with another 3x minus 2. That common factor of 3x minus 2 comes out, leaving 2x minus 1. That will be the upper left. 4x minus 8 will turn into 4 times x minus 2. Up top here, we have 2x squared minus 7x plus 3. And so we need two numbers that multiply to 6 and add to 7. That sounds like negative 6 and negative 1. Okay, so let me see if it works. We'll factor out a 2x here. That will leave x minus 3. Once again, a negative comes out so that we end up with x minus 3. Factoring out the x minus 3, we'll be left with 2x minus 1. Okay, down below, that x squared minus 5x plus 6 will be x minus 2, x minus 3. All right, so once again, I'm going to recopy this problem, and when I recopy it with the factoring included, I'm also going to do the kind of invert and multiply piece. So the first fraction will stay the same. We don't form the reciprocal of the first fraction. So we'll have 3x minus 2, 2x minus 1. Down below, we'll have 4 times x minus 2. Turning division to multiplication, we'll now have the x minus 2, x minus 3 in the top. And then the x minus 3, 2x minus 1 in the bottom. Okay, so there's a fair amount of work on each of these because we had to factor a bunch of stuff. But let's see what we get to divide out now as our reward. So I can see a couple of 2x minus 1s that can be divided away. I can see a couple of x minus 3s that can be divided out. And it looks like we also get an x minus 2. So that's pretty great. We don't always get so much stuff. So x minus 2's divide out. So all that's left is a 3x minus 2 in the numerator and just a 4 in the denominator after all that. All right, so our grand finale here is just to simplify because it's a combination of a division and a multiplication. So we have one fraction divided by another. And then once you've gotten that done, multiply by the n plus 4 over 8n squared plus 12n. So for this one, pause the video and then try it yourself and then restart the video and see how you have done. So as we did before, I'm going to begin with all the factoring, okay? All right, so let's see how this comes out. So I just did a whole bunch of factoring first, and I'm just going to put together the pieces. 2n squared plus 10n was 2n times n plus 5. The n squared plus 10n plus 24. Here we needed two numbers that multiply to 24 and add to 10. That would be 6 and 4. So we factored that accordingly. N squared plus 8n minus 9. The two numbers you need for that would be plus 9 and minus 1. For the last part, 8n squared plus 12n, we're going to factor 4n out, leaving 2n plus 3. So now trying to put together the pieces, the 2n squared plus 10n worked out to be 2n, n plus 5. And then down below that, the n plus 1 stays where it is. Sorry, that was in minus 1. And then at this point, we have a division. We're going to turn that into a multiplication. So the n squared plus 10n plus 24, that should end up in the bottom. So we'll have plus 6, n plus 4. The n squared plus 8n plus 9 is now at the top. That's n plus 9, n minus 1. And then lastly, we have n plus 4 in the top. And the 8n squared plus 12n, that was 4n, 2n plus 3. Okay, so let's pause there for a quick second. Make sure that you're good with all the factorizations. And then at this point, if we're lucky, we should start seeing some things that divide out. So it looks like an n minus 1 divides out here. I think I see an n plus 4 as well. And then I see 2n and 4n. So that is divisible by 2n. So let's see, is that everything? I think that's everything. So what's left? We have n plus 5 times n plus 9. And then down below, we'll have n plus 6, 2, and then 2 and 3. All right, so that's how that looks factored. Let me go ahead and multiply it out as well, so it looks a little maybe nicer. We'll have n squared, 14n, and 45 in the top. And then down below, we should have 4n squared. And then that's 12, 15, 30n. And then lastly, 6 times 3 is 18 times 2, 36. Okay, so that does it, and that finishes multiplication and division of rational expressions. We saw that the patterns kind of follow just directly from arithmetic, right? For multiplying, you multiply across. For division, you do this thing with the reciprocal and then multiply across, simplifying along the way. The difficulty comes in just keeping track of all the details and making sure that you get all that factoring done correctly. Anyhow, that takes us to the end. Let me know if you have any questions and have a great day.